I'm Jack Turbush, team lead of FTC 1002 Circuit Runners Surge.
And I am Aiden LaCroix, team lead of Circuit Runners 11347 Blackout.
So just going to go over what is 3D printing if you don't know already. So 3D printing is a method of additive manufacturing that basically builds parts in layers. So it's just a layering process of many different layers of thinly printed plastic. So it melts the plastic and then into like a 2D platform and then makes like a million different layers of that. So it takes a 3D model from CAD and then extrudes it upwards into a real part.
And you can do a lot of things with these 3D prints. Like, for example, you can print, you can go meta and then print parts for your 3D printer. And you can modify it in many ways. You can even modify the internal components or the extruder. In this case, a friend of mine printed a webcam mount for his 3D printer as to where he could record and stream his 3D prints.
So now we're going to go over the types of 3D printers and how plastic is extruded. So basically, there are a wide range of types of 3D printing. The first one would probably be like one of the more expensive ones is called SLS or selective laser sintering. Basically what sintering is focusing laser beams together and onto like one point in space within a material to harden it. And then therefore, if you have a computer focusing these lasers in different spots inside the material, you can eventually get a solid material from that block of material. Basically like solidify most of it and then shake the rest away, and then it creates an object you want.
And then when you do SLA printing, it effectively is the reverse of a regular printer, and you print from the bottom up. So there's a layer of resin, and then a build plate lowers down into it. And so then a bunch of different lasers are refracted using mirrors to harden specific spots. And this type of printing is extremely accurate and extremely detailed, but also very expensive and very time consuming. And also pretty messy because of resin.
Mm-hmm.
Yeah.
So basically, those two types of printing are super expensive and super hard to access as a normal robotics team. So what you would want is like meeting in the middle with a fused deposition modeling 3D printer, which basically is your normal. You have a spool of filament, a spool of plastic, and then you extrude it into an extruder, and then it prints out in many different thin layers. There's no lasers or anything involved. It's fairly simple, and this is probably the most used form of 3D printing in the world, and it starts as low as $200. You can buy a 3D printer off Amazon. It's crazy how far technology has gone.
So filament, you need filament to print anything, and it comes in a number of different materials and a number of different width. Filament width is extremely important, or the diameter of the filament, simply because if you get the wrong filament, it's not going to work with your printer. So whatever printer you might have, if you have one, you always want to make sure the filament you're getting is the correct diameter. Additionally, you want to make sure you're getting the correct type of filament, as if you run the wrong type of filament on the wrong settings, it could mess up your 3D printer. You'll have to spend hours cleaning it. I've done it before. It's not fun. But it comes in many different colors, many different materials, and we'll talk about more materials later.
So now we're going to go over the actual extruder part, the part that extrudes the plastic into these layers that we've been talking about. Basically, every 3D printer, every at least normal 3D printer has a hot end where it basically melts the filament into temperature exactly where right when it's released from the hot end, from the metal part of the extruder, it becomes cooled, and it's at that threshold around 200 degrees Fahrenheit. So one type of extruder is called a direct drive extruder, which involves a hot end and then a little set of gears to push the filament into the hot end and do it at the right speed for your object's layer height, for your object's speed, and for your extruder's overall speed as well. So this type of extruder has a lot of benefits. It has fast extrusion. It has fast retraction. The motor is actually very close to the hot end, so therefore you won't have much lag in your 3D print system. So You don't have to deal with friction or anything. There's less stringing and oozing, and it's better at printing flexible materials because your filament doesn't have to pass through anything like about an extruder, which we'll go over in a second. Some of the weaknesses include, however, are it's a large mechanism. You have to include a whole gearbox, a whole stepper motor, and a hot end extruder. So it's huge, it's very heavy, and therefore all the motors that are moving around this extruder on your 3D printer have to work a whole lot more, and they have to move around that a lot of mass. So therefore, when it's doing really precise, when the 3D printer is doing really precise jobs, it can overshoot. So the mass will just cause it to overshoot where it's supposed to go, and that could cause like spillage off the sides of your object, and it just won't look that uniform. And it could be a lot more accurate.
So a Bowden extruder is what you'll see on most budget 3D printers. For example, this is the Ender 3 or the Ender 3 Pro, both very good printers and both very cheap, but a little limited on technology as it uses the Bowden extruder. So the Bowden extruder is great for most things. It's fast, it's quiet, it's very compact since you don't have the mechanism to move the filaments there. The mechanism, as you can see on the right, is actually elsewhere on the printer, and it feeds it through the long tube, which then feeds it into the hot end where it is extruded onto the actual build plate. And so it's very accurate due to less mass. And normally on a direct drive printer, it won't be necessarily less accurate, but they'll be more expensive to counteract the extra technology you have to make it run better and more accurately. But Bowden extruders are bad for flexible filaments like TPU or nylon, just because it has to run it through the tube. And direct drive does not have that problem.
So now we're going to go over materials that you can use for your 3D printers. First one, probably the most common, the most cheap, would be PLA, or polylactic acid. So polylactic acid is what you use for quick prints. It's an average kind of strength, but then it begins to lose form around 60 degrees Celsius. But you can use it for most projects, and you'll get a pretty solid object. But you don't expect it to hold up to really high strength, and it breaks easily, basically.
TPU is normally not something you'd use in a robotics context unless you need a very specific part. It's flexible when it's thin, or it's just flexible in general. But it's more expensive, and you have to with a Bowden extruder, like I was talking about earlier, it will probably mess up, and it won't come out correctly. So it's good to have a specialized print, and you have to make sure you set your settings properly for each of these different types of materials, which we will go over later.
The next type, which is probably one of the stronger plastics, one of the most strong and durable plastics, is called ABS, or that set of words that I can't pronounce. It has a higher heat resistance, and it's just super strong and durable. Fun fact, it's actually what Legos are made out of and what they extrude using. So some of the downsides, though, it warps easily when it's not printed properly. So in order to print it properly, you need a heated build plate, a heated bed, and an enclosure to protect the plastic because it's really sensitive while printing. It's a similar cost of PLA, but make sure you guys have to keep your area well ventilated, as there are some dangerous fumes associated with ABS as well.
Nylon is another one that is very strong. We also have to have very specific settings and a very specific type of printer. But it's flexible. It's flexible, just like TPU, but stronger than TPU. However, it's also moisture sensitive, but it can absorb color. So it's useful for if you want to print something nice looking, not necessarily for a part. It could be useful in some contexts, but for most contexts, you'll want to stick with PLA or ABS.
And probably like in between all of these is probably PETG. So PETG is very strong, which is like almost ABS levels of strong. It's really good for mechanical parts, and it's also very thermally stable. But one downside is it's pretty expensive compared to the others. So just keep that in mind when you're purchasing. PETG would probably be the best option, but not for cost efficiency. So now we're going to go over how to 3D print an object from your digital file into an actual object. What you'll need, a 3D printer, you need your right filament that you want your part to be made out of, and a slicer software. Basically, a slicer software is something that prepares your digital file or your digital object into something that can be printed. It's basically like a G-code file, they call it, which is like a machining instructions. It gives the 3D printer a path and then how to create the entire object. It's just a whole set of instructions. There are
And
three. Sorry.
Oh, sorry. And G-code files are very standard, though you'll find like G-code works files work with most, if not all, 3D printers. And they also, if I'm not mistaken, work with CNCs in the same way. You have to use a different software, but they're all G-code files.
Yeah. G-code is basically the standard for manufacturing most parts. So in order to take your STL to a G-code file, you probably need a slicer, and these slicers include, there are a million different slicers, but the one we use most often is probably Cura, which is the one on the left, but there's also others like Slicer with a 3 and Matter Control, and they're all free, so it's really easy to download and get into. There's a bunch of stages to 3D manufacturing, which you guys will go through. There's either CADing or using computer-aided design software to make an object in 3D, like SolidWorks Fusion 360 or Inventor to design your part, or you can just download it off an online database. So basically you want the STL file from any of these. So after you export your part to STL, and STL is basically short for stereolithography file format, which basically turns your vector-based object, or you're like geometrically like take the circle that you see at the bottom. It's perfectly circular. What the STL basically does is makes it easier to print and easier for your slicer to process by making it into a triangle mesh, as you can see in the bottom. And then Cura or any other slicer software will take that STL file and export it to G-code. As you can see in the bottom, it's a bunch of little layers and stuff. It's basically slicing up your STL into a layer height that your 3D printer, into like a million different layers that your 3D printer will then print. And then after you do that, you upload it to your 3D printer and then press print. But it's a little bit harder than that, and we'll go over all the specific settings and things you should watch out for in your 3D printer right now. Actually, in a second.
This is just Cura, kind of a little bit more in detail. You can see the general user interface. So you would just open your file, your STL file from here, and it would show it to you. You would make sure that it's the correct dimensions because you'll often have issues, especially if you're going from a non-standard CAD software with dimensions. So make sure your dimensions. It shows you dimensions in the bottom left. Make sure everything looks okay, and then you have your settings. If you have a print that is kind of like has a lot of it's off of the build plates, that's not supported by other parts of the print, you would check the support box. And there's a bunch of ways you can support something. I believe Cura auto generates it, but if not, there's also a bunch of guides on how to do that. And you would set your infill and your layer height. Now, if you set a lower layer height, it'll take a lot longer, but you might get better results. Not always, but sometimes. Your infill percentage will if you set it to a high infill, it'll be a lot sturdier, but it'll also take a lot longer. And then there's a bunch of other settings you can also configure. You can also configure your actual print temperatures in Cura. And they have a database of 3D printers you can select from just to get the diameter, nozzle diameter, and print temperature. But you always want to double check your settings for depending on which filament you're using, and always check the box of your filament to get the recommended temperatures for both your build plate and your extruder.
Yeah, a lot of this is dependent on the type of 3D printer you use. And just to go over infill real quickly, so basically infill is how dense your object will be full of plastic. Generally, you probably don't want your print to be solid plastic, solid layers of plastic. So usually people will check this infill box, which is just how much percent of your part will be actual plastic, and it'll print in like either a hexagon format, triangle format, just a bunch of like a whole pattern, just so there's a lot of empty space inside that makes your part lighter, and also increases the amount of time or decreases the amount of time that it takes for your 3D printer to print, because that's also something you should take into place. Because if you were to print this boat fully 100% infill, it would take hours and hours on end. But if you reduce the infill to 20%, then it'll be a lot quicker and still have the sturdiness you need. So just depends on what parts you're making and how sturdy you want it to be.
So when you're printing something, you always want to have a starting point. Now, most 3D printers just default to the skirt, which is it just literally like creates like a square or a circle. It just like kind of like mimics the shape of your 3D of the base of your 3D print and draws it around it. And this is useful to double check if your 3D print is having issues or to see if your bed is leveled correctly, which we'll talk about in the next slide. But yeah, skirts are very easy to see exactly what your 3D printer is, where your 3D printer is printing, and if it's rubbing up against the base or not.
Mhm.
A raft is generally used with ABS, just because ABS has a tendency to warp if it's not properly secured. So it pretty much adheres to the base in a wider area. And also, if you're printing something that has not really a solid base, but more like legs or small parts touching the build plate, then you'll also want to have rafts on each of the contact points if the contact points isn't large enough. That way your print doesn't fall over during printing or warp during printing. Finally, you have the brim, which is just useful if you're just printing with any sort of filament. If you really don't want to print a fail, you would probably use a brim, and it's also helps with bed adhesion, and it shouldn't warp if you properly use a brim.
Yep. So we'll go over a couple problems that you'll see and you'll have to learn from and adjust your settings like accordingly to make your prints turn out a lot better. So basically leveling your bed. Your bed comes, like most 3D printers have this bed that you have to adjust and adjust its levelness. So when it prints, part of your print won't like be coming off the build plate. Everything has to be that right amount of secured or have that right amount of contact with your bed. On the left, your bed is a little lower than it should be, so it just starts printing the plastic and then can too easily just peel off your bed. On the right, your extruder is actually just really too close to your bed and just scraping along the your build plate. So that's not good either. So you have to find a happy median between the two.
And another issue you might run into similar to this is your bed isn't adhering even though it's leveled properly. If you have a glass bed, you might run into this a lot. One of the things I've found that makes it adhere a lot better is if you use like hairspray. Actually, just spray your entire build plate with hairspray, and then it sticks a lot better if it's a glass plate. Tape also works on glass plates, but I've found either glue stick or hairspray works like is a lot more permanent solution.
Mm-hmm. So yeah, here's another example of too high extruder and then too low. And one other thing about something you can edit in Cura actually is your layer height. Basically, your layer height basically kind of also judges your strength of your part. So if you have a lower layer height, it'll be a lot stronger because all the plastic is more melted together and has less opportunities to like separate. The median layer height is probably where you want to be. And then some layer height that's too high can make it a lot easier for your part to just snap in half, because all the parts aren't that melted together and it's a lot more distinct layers than other examples. So.
And now finally, what can you really use 3D printing for? Well, you can use 3D printing for pretty much anything, any like specialized part you need that doesn't necessarily need to be holding up your entire robot. So just for everyday use with your robot, it's really useful for wire management clips or for string management when you're working with pulleys. We've done that a lot on our team, and also phone mounts. It's extremely useful for phone mounts or battery mounts in FTC. Um, so you can just print like a simple phone mount and then use zip ties, and it works a lot. You can make it a smaller profile, and you can fit into better places on your robot. And for battery mounts, you can make a much better battery mount with a actual lid. There are a lot of actual 3D prints already available on the web for that sort of thing. And it's also useful for If you wanted to temporarily substitute a COTS part, you could do that, like a bracket or a simple spool. And it's very useful if you just need a specific dimension of a specific part.
Yeah. All right.
So that's all for us. If you guys have any questions, we'd love to hear them in either chat or the Q&A. Anyone? Can you comment on better and worse printer and brands and models? So personally, I use an Ender 3 and it works great. It's by Creality. That's a pretty good budget printer. I've heard good things about the CR10 and the CR20. And Jack, what printer do you have? Do you have a?
I have an Ender 3, just regular Ender 3, not the Pro, and it's really, really good. It's really cheap. It gets the job done. It's pretty great.
I can't think of any necessarily bad brands that that you'd want to stay away from. Make sure you do your research before, and make sure that it's what you want to look for in a printer most of the time is reliability, and like make sure it's got good documentation online.
Mm-hmm.
So definitely do your research when you're looking for those.
Yeah. No problem. You can basically just order these off Amazon, and it's like a fun little kit that you build, and screw a couple things together, and then in an hour your printer's ready, and it's great.
Oh, how do you clean the tip when the filament oozes out of it? So one thing you can do is you can use a. It helps to occasionally heat up. You can kind of scrape it away if the while the hot end is hot. You don't have to worry about damaging it. But yeah, if the hot end is hot, the filament around the tip comes off much easier. And you can kind of try to scrape it off without doing that. It's just a pain. But it's pretty simple if you just heat up the end. You can use a wet rag or a scraper.
Yeah, sometimes I even use some wire cutters as the filament's leaking out of that. I just snap it off because usually it's not actual melted plastic right when it comes out of the hot end. It just hardens and is really stringy. So some wire cutters and snip it off.
Oh, what causes filament to ooze out of the tip? One thing that can cause filament to ooze out of the tip is if you it's kind of unavoidable if you're heating up for a print. Occasionally, it might just leak out a little bit if there's already some in the tube, and you can just kind of like wipe it away before your print, and it should be good. But if it does that a lot, you might want to check on the actual extruder parts, which on a Bowden will be on the actual frame of the printer, and make sure that it's not pushing when it's feeding when it's not supposed to be. No problem.
Are there any other questions?
All right. Well, thank you all so much for coming.
All right. Thank you, Jack. Thank you, Aiden, for this wonderful presentation. And thank you to the audience for coming. This does conclude the end of the presentation, so you may leave.